So what would you like to see? C? Okay. Oh, I did lie to you on this one. It's not the last example anymore in the lecture, okay? But just trust me, you can look at example 4 out of your book. You'll see how long it is using direct methods to evaluate this thing. But using the divergence theorem, it's going to be no problem. Okay, so in this problem, F has components z, y, and x. S is the unit sphere, and then other stuff about how hard it was doing it directly, and note how much easier this method is. So what does the divergence theorem say? It says something about flux. So the generic flux, so what's the generic representation of flux? F dot n ds. And then what does the divergence theorem say about the flux integral? Now, what has to be true about S for the divergence theorem to be true? S has to be what kind of surface? Has to be a closed surface. And you know, the surface is well behaved, the solid is well behaved. So it's a triple integral, right? E is the interior of S. What's the integrand? Divergence of F, and then dV, if you like. So let the formula be your guide. What's it telling you to find on the right-hand side? Divergence. So what's the divergence of F? Okay, that's del dot F, right? Well, I think you might be onto something there. Well, let's take a look. So z, y, x. So it's not quite everything is 0, right? d dx of z is certainly 0. d dz of x is certainly 0 on the end. But in the middle, d dy of y is 1, right? So we do get an integrand at 1. That's kind of neat, right? So, yeah, it's going to be volume. So if I set this thing up, then I'll just say, instead of writing out the flux integral, I'll just say flux. The flux capacitor, does anybody think of that when? Yeah, me too, yeah. Okay, it's going to be the triple integral over E, which is the unit sphere and its interior, right? And then 1 dV. Does everybody agree with that? So if you realize that E is the unit, I don't know, unit ball, or, you know, it's the unit sphere and its interior. It's the solid sphere. What does it mean when you integrate 1 when it's a triple integral? It's going to be volume, and hopefully you know the volume of a sphere is 4/3 pi r cubed, right? So 4/3 pi, what's the radius of the unit sphere? Yeah, 1. So just 4/3 pi. So yeah, not too bad, right? And if you do make that comparison where I put too many parentheses, yeah, I did put too many parentheses. Yeah, I did. But if you make the comparison with the other problem, this is way, way easier.